modeling and predicting crop health using remote sensing data and neural networks. Hello everyone. Today we will go through a Python script that processes and analyzes satellite images to assess vegetation health. We will use several libraries such as numpy, pandas, rasterio, geopandas, and TensorFlow. In step 1, let's import the necessary libraries. These libraries will help us handle data, perform calculations, and build our model. You can download the used data in this repository and extract it into the data directory of your notebook. We load the raster data using rasterio. We have 3 types of data: DIM, digital elevation model; ortho, a multi-band image; and DTM, digital terrain model. Next step is read arrays from raster data. We read the data from the raster files. For DIM and DTM, we read the first band. For the ortho, we read 6 bands. Next step is load vector data. We load vector data, which contains plot information, using geopandas. Next step is mask invalid data. We mask invalid elevation and thermal values by setting them to none. Next step is calculation NDVI. NDVI, or Normalized Difference Vegetation Index, helps us understand vegetation health. We calculate NDVI using the formula near minus red divided by near plus red. Now compute zonal statistics. We calculate mean values of NDVI, thermal band, elevation, and DTM for each plot. Firstly, we define compute zonal status. Status equal mean. After that, we apply compute zonal status for NDVI mean, thermal mean, elevation mean, and DTM mean. Now we start with data preparation. We remove any none values and prepare our features for model training. Now let's create target variable. We create a synthetic target variable that focuses on healthy crops. We define healthy crops based on NDVI values, as example between 0.4 and 0.8. Now we check data balance. Firstly, print class distribution to check for imbalance, then handle data imbalanced by undersampling the majority class, then separate majority and minority classes, number 1 healthy and number 0 not healthy. Resample majority class to match the minority class size. Finally, reassign features and target from the balanced data. Next step is split our data into training and testing sets by 0.2, which means 20% for test and 80% for training. Next step is standardized data. We standardize the features to have zero mean and unit variance. Now we define a neural network model with 3 layers. We use the ReLU activation function for hiding layers and sigmoid for the output layer. Then we compile the model using the Adam optimizer and binary cross entropy loss function. Then we train the model for 100 epochs. Next step is evaluate the model. We evaluated the model on the test data and calculate different metrics. Accuracy on test data 0.95. Now make predictions. Calculate evaluate metrics. We compute accuracy, precision, recall, F1 score, and ROC IUC score. Accuracy score 0.95, precision score 1, recall score 0.9, F1 score 0.95, and ROC IUC score 1. Finally, we plotted the confusion metrics to visualize the model's performance. We use Seaborn library and create heat map. After that, display it. That's the confusion matrix output of the result. In conclusion, we learned how to process remote sensing data using Python, compute important vegetation indices, and train a neural network model to classify vegetation health. Thank you for watching, and I hope you found this session useful.